Hello everyone, this is Rohit and welcome to my YouTube video of class 1200 and coach is Mr. Bias. In this video, I'll be covering about SVM and Naive Bias. So let me introduce myself first. So this is my college, Devon College, and this is assignment 4 and my coach is Mr. Bias. And we have got a CSV file that has all the variables such as cell, smooth, infill, blast, and the minus. And release is a dependent variable and all the others are independent variables. So we have to calculate SVM and Naive Bias. We have to predict, we have to get the prediction, FM score, all the other values for these variables. And so let me open the code and let me, So this is the data which Sora has given to us. LGPU analysis new.csv. And in this code, we are first importing the pandas and numpy. Numpy is mainly used to calculate for the calculation purposes and matplotlib. And now we are loading a data set here. How do we load a data set? I just assigned these values into a DF and reading this CSV. The CSV which this one should match this one. So it will just get this file here. And df.head, and if it's blank, as we know, it will pull out the first 5 values in this. If you want to increase it, you can increase it to any number within the range. So now we can see the range has been increased to 10 values. And now df describe is used to calculate the mean, standard deviation, median, minimum, 25%, 50, 75, and max values. This is a standard template which Python has given us. Now we have to create X and Y variables to scale the data. And now in this, from a scalar model selection, so from in this X and Y axis, we are dropping off the remes, and rest all the values we are sending it to X axis. Drop remes in the sense. So for example, if this is the case, I'll just keep print X so we can understand it better. Print X, and just if I execute this, we can see. So all these values 0 0.8, 0.83, 0.66, 1.9, 1.1, and 1, which is similar to this. And remes didn't change here because we already dropped the remes here. So likewise, we are only importing remes to Y axis, and then creating the testing and training data sets. So when you are selecting the stress strain split, so when you are going into this one, in this source code, this is the basic template which Python has already given. We just need to fill all the details with the requirements. So in this particular place, you can see this is the basic template which this one, the Python has already provided to us. And in this, the test size we have taken as 0.2. And if you take test size as 0.2, you will get only 20% of the data. And yeah, this is a wise decision. The train data will be like 80% and the test data will be like 20%. Now, if you want to check that as well, let me remove this one. And if I go here, and if I try to print X test, so here the system will automatically suggest what's the variable we have already used. We can just reuse that. And now you can see it only pulls 20% of data. If I keep it as 0.5, just see now it has already taken half our data into this. So that's how it is calculated. And now we are just importing the standard scalar from SQL pre-processing. Now we are doing for the train 2, we are doing the fit and transform. Fit is basically used to calculate a particular value, and transform means used to apply the particular value. And in this SC transform, since it's already calculated, we are just assigning some of the values to X test. And that's what it is. It says. And in this script for SVM and NB, we are just importing SVC from scalar SVM module, and Gaussian NB from Naive Bias module. And now from the metrics, classification report and confusion matrix has been called into this report. Now, if you want to take a closer look, this is the main method which we are using to get the precision recall F1 score support. So we get the values from this. If you want to check the entire source code, you can have a look at here. It is performing some calculations over here, and it is pulling out the values here. And then in this fit, we are in this, for this name and method, this is a naming convention where you're calling name or the module and the method. And these are the parameters. Kernel is linear and random, so we have assigned as 100. And in the Naive Bias is a module which is name, and the method is Gaussian and Naive Bias. And we are calculating the values and assigning those values to X train to and Y train. And here the target names we have taken as remis, because this is a dependent variable. And in the remis, you can see in all 1 and 0, it's a, you can say an array as 1 comes 0. So now with that, we're just printing all the precision recall F1 score and support. Now, when you go back to this PPT, here we have so these are the mathematical derivations for all the accuracy, precision, F1 score and recall. This is what we have, this is what all this code in this particular Python says. If you can have a look at it. So this is the basic code which is already written in this. And for the precision, there should be some particular code assigned. So labeled micro average, compute all the averages. Yeah, we can have a look at it. Since I don't have enough time, but the time is limited for this assignment for the video. So I'm just explaining the top layer. And then when you go back to the PPT, we're just comparing those. And here the precision values are precision values for 1, for the target name 1 is a little more when a little less when compared to for SVM, it's a little less when compared to Naive Bias. But when it comes to 0, it doesn't show any values here, but there are some values here. So in this screen, we can clearly see that 0.33, 0.0, 0.50, 0.0, 0.40, and 0.0. So that says we are just comparing of SVM and Naive Bias here. In this first row of the SVM matrix indicates the ranges, which has 2 correct and 2 incorrect answers, like this. Here there are 2 correct and 2 incorrect. The second row contains the correct and incorrect ranges. So in this second row for 0, there are values present here and there is none present here. So the first row of the Naive matrix, which has 4 correct and 0 incorrect answers, remis is in the second row, which with 2 correct and 0 incorrect answers. And the micro average, so all these accuracy, micro average, weighted average, we can see here in this code, which is already written for these calculation for these values. And here we can see the precision values are a little more when compared to the precision values of Naive Bias. So when we compare now, when we compare with SVM with Naive Bias, I would suggest SVM is the best practice. And these are the recommendations and justifications which I would do. And in the recommendations, Mr. John Higgs has the SVM algorithm because it will help him produce more accurate results. So here, the end results clearly show us the SVM has more accurate results when compared to Naive Bias. And this is a simple formula which is derived and it is easy to calculate. Whereas in Naive Bias, little difficult and the values are not that accurate. And then in the justifications, in terms of this precision recall and reference score, SVM and Navy algorithms differ only slightly. We have we choose the SVM algorithm for the following reasons. The reasons are as follows. The Navy algorithm can assist in calculating the probability of the data sets independent variables. Also, because its estimations may be incorrect in some cases, we can trust its output. Second, it takes a long time where we have a large number of independent variables with correlation. The SVM algorithm is best suited for implementing the hyperplane and separating the values because it always produces more accurate values. And that's it for today. Thank you so much. Bye-bye.